Welcome to our discussion topic of the day. We are going to talk about alkanes and isomerism in alkanes. So, what is isomerism? Isomer formula is the same, but the appearance, structural formula means the structure of that element or of that alkane, how it appears is different. Now, for example, we're going to talk about butane and pentane. So the type of isomerism that occurs in alkanes is what you call a branched chain isomerism. Okay, branched chain isomerism, because we are saying in our chain isomerism or our branch chain isomerism, you have two or more compounds. So we are going to have two or more compounds forming from our butane or pentane or any alkane, okay, which shows isomerism. So we are going to have two or more compounds with the same molecular formula but different structural formula. The structure is going to differ. And this occurs because of the possibility of a branching occurring from our carbon atom. So the possibility of branching from our carbon atom is going to bring about isomerism. Now, let us do the first one. So the structure of our butane is going to be like that. We are talking about the structure, okay, structural formula. So we have 4 carbon atoms. We have our 10 hydrogen atoms. There, as you can count, you can see we have how many? There are 10 in number. We have 3 here. We have 3 here, that is 6. We have 2, 2, 8, 2 here, 10. Okay, so this is our butane. So we have said there is a possibility of branching occurring in a carbon atom. So if the possibility of branching occurring, then you're going to form an isomer of our butane. So what is our isomer here? So the isomer is going to be, we are going to draw 1, 2, 3, okay. Then we're going to have a carbon atom there. Like that. Here we're going to have hydrogen, hydrogen. You have a hydrogen, then you have hydrogen, then you have hydrogen. How many carbon atoms do we have here? We have 1, 2, 3, 4. 4 carbon atoms, as you can see. Hydrogen atoms are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. So you can see we have the same molecular formula. This structure gives us the same molecular formula, which is C4H10, as this one, which is also C4H10. We're going to name our isomer in this case. So the first thing is you identify the parent chain, okay? When you identify the parent chain or the longest carbon chain, which is 1, 2, 3, you have 1, 2, 3 carbon atoms. That is our longest carbon chain. As you go like this, it's also 1, 2, 3. After you have identified, now you're going to write the name somewhere. So if you have 3 carbon atoms, it means your element or your substance is propane. Okay, now after you have identified it, what are you going to do? You're going to now identify the branched group. In this case, it's our methyl group, and you're going to identify it or label now again your isomer starting from the side which is going to give you the methyl group the least number possible. So which is 1, 2, 3, meaning the methyl is in carbon number 2. 1, 2, 3, meaning the methyl group is in carbon number 2. So we are going to say now, when you're labeling our isomer, it is going to be 2-methyl. So we are going to write it as, so we are going to write it as 2, okay, methyl, because this is a methyl group. This is our methyl group, and it is in carbon number 2. So it is 2-methyl. 1, 2, 3, we have propane, 2-methyl propane. So that is the isomer of your butane. We have two isomers, which is this one, which is what we call butane or N-butane, N standing for normal, okay? We have N-butane and we have 2-methyl propane. So these are the two isomers of butane. Now let us go to pentane. Now we have said it only occurs, isomerism occurs where you have a possibility of branching in your carbon atom, and that's why you can see that methane and ethane as well as propane cannot exhibit or do not exhibit what? Isomerism. Now when you go to pentane, we can write the open structural formula of pentane, okay, which is going to be 5 carbon atoms, 1, 2, 3, 4, 5, and your hydrogen atoms. So that is the first one. Now we are going to look at the possible position of, or the possible branching positions that we have here. So we can first do what? We can come and write. The first one will be 1, 2. So you can have 1, 2, 3, 4 carbon atoms, and we can have this methyl group. So we can have this methyl group, this last one, okay? We can have that methyl group detaching. We can have this methyl group detaching and reattaching in one of our carbon atoms here. So we are going to put it here, this methyl group. So we are going to have the hydrogen, hydrogen, and here we're going to have what? Hydrogen. And then also this is going to form a hydrogen bond there. So there, like that. Okay, so we can start naming this one. So we said the rule is what? First, to identify the longest carbon chain. After you have identified the longest carbon chain, in this case it is 1, 2, 3, 4, because if you come like this, it is 1, 2, 3. So the longest is 1, 2, 3, 4. Okay, now meaning if it is the longest carbon chain has 4 carbon atoms, it means that our element is going to be a what? Butane. So you put it down somewhere. So that is the longest. And then now we come, after you have identified the longest carbon chain, you come and you number, or you identify, you label now your compound or your isomer from the side that is going to give your group or your methyl group the least number possible. So if you start from this side, the methyl group is going to be in carbon number 1, 2, 3. If you start from this side, the methyl group, this one, is going to be in carbon number 1, 2. Okay, so when you're naming, we are going to name our isomer as, it is the methyl group is in carbon number what? Number 1, 2. So our compound is going to be, our isomer is going to be 2. You put a hyphen. Remember, we say that is what we normally do. 2-methyl. The parent name was what? 1, 2, 3, 4. It was butane. So it is 2-methyl butane. So that is one isomer of pentane. We're going to have, we have how many carbon atoms? We have 1, 2, 3. Okay, and then we're going to have the first methyl group here, and this other methyl group also there. Okay, so this is another isomer of pentane. So how are we going to label? You identify the longest carbon chain. It is 1, 2, 3. Okay, it can also be 1, 2, 3. See, can have it as 1, 2, 3. It can also be 1, 2, and 3. So meaning the parent name is going to be propane, because that is the longest carbon chain. Propane. Okay, Name of our isomer is going to be 2. The methyl group is in carbon number 2. 2. We have another methyl group. The position of this methyl group is 2. Remember, these numbers show us the position of our group, of our branched group, okay, the methyl group in this case. So we have 2, 2, and because there are 2, we are going to say dimethyl. The longest carbon chain is propane. Dimethyl propane. So that is how you write isomerism, or that is how you work out isomers in alkanes.